When you look at a dense modern city, the biggest problem facing civil engineers is obvious. There is zero extra space. If you want to build a towering new skyscraper here, the traditional bottom-up method is a massive liability. Digging a cavernous hole right next to existing buildings threatens their foundations, and it takes months of excavation before you can even begin pouring the actual structure. The solution to this spatial gridlock is a counterintuitive engineering technique. Instead of starting at the bottom, you build the roof before you dig the hole. This is top-down construction. By reversing the traditional timeline, crews can secure the site perimeter immediately and cut the overall project duration in half. It is the exact technique that makes these deep urban basements possible in the tightest spaces on Earth. To see how this works, we start at ground zero. The immediate objective is complete isolation. We have to cut the underground construction site off from the surrounding city infrastructure. Step 1 is the diaphragm wall. In this 3D cross-section, teams dig a deep trench along the entire boundary, filling it with reinforced concrete. The surrounding earth and groundwater are constantly pushing inward. This wall physically blocks that immense pressure. But that creates a new engineering challenge. How do you support the heavy weight of a future building if you haven't dug a traditional foundation yet? Step 2, solve this. Crews drill deep vertical boreholes inside that perimeter, well below the future basement depths. Then they lower heavy steel plunge columns straight down into those holes. The site is now barricaded from the outside pressure and anchored deep on the inside. And because it all happens underground, from street level, it looks like nothing has even started. Step 3 is where the process flips. Teams pour a thick concrete ground floor slab directly on top of the existing dirt surface. If they seal the top of the site with a massive concrete floor, how do they get all the dirt out from underneath it? This top-down view of the ground slab shows the workaround. Engineers cast the floor with several massive square access openings left intentionally empty, exposing the earth beneath. This initiates step 4, the downward descent. Surface cranes carefully lower specialized, compact excavators straight down through those openings. Operating entirely enclosed under the new concrete canopy, these machines scrape out the earth and load it into skips, which are then hoisted back up to the surface through the shafts. As the dirt is removed, that concrete ground slab performs a vital secondary function. It acts as a massive horizontal brace. It locks the top of the diaphragm walls in place, preventing them from buckling inward under the city's pressure. The ground floor operates as a dual-purpose shield. It provides necessary structural bracing below, while offering a flat, stable staging ground above to start the real mechanics of the top-down method. Now we arrive at the primary operational advantage. We get to do two things at exactly the same time. Step 5, simultaneous construction. As excavators reach the first basement, above-ground crews erect the superstructure. A new slab is cast below, locking plunge columns into place. The cycle fast-forwards, digging deeper and casting successive basements, while above-ground teams simultaneously build multiple floors upward. Eventually, the downward excavation reaches its final depth, the lowest subterranean level. Step 6 is pouring the base mat, also known as a raft foundation. This is a massive, incredibly thick layer of concrete at the very bottom of the pit. Those steel plunge columns are completely encased into this base mat. The entire weight of the skyscraper towering above is sent straight down the columns, into the mat, and safely transferred into the earth. The top and bottom halves, constructed independent of one another, are now merged into a single monolithic powerhouse. Looking at the completed structure, it is entirely seamless. The everyday public walking by on the sidewalk has no idea a massive multi-level fortress was built right beneath their feet. This Gantt chart shows exactly how much time is saved. The top bar shows the long, sequential phases of bottom-up construction. The bottom bar shows the overlapping phases of the top-down method, condensing the schedule and saving months of waiting. In high-value urban real estate, saving 6 months of construction time means massive reductions in financing costs, while minimizing the collapse risk to adjacent properties. Modern engineering consistently turns extreme spatial constraints into timeline advantages. If you want to learn the exact mechanics of how they construct that crucial diaphragm wall deep underground, hit subscribe, and we'll break it down in the next video.